Good evening, all of you. First of all, thank you very much for sparing your Sunday evening to what I hope will be a lively discussion on the Indian science in particular, and both its achievements and its limitations. And there are a lot of claims about Indians did this, Indian did that. And rather than going by something that somebody has said, by the end of the lecture, I hope I will have given you enough confidence that on your own you can judge whether what is being claimed is correct or not. But the first large part of my talk, I will talk about some of the great achievements of Indian science. After all, it's a civilization that has lasted several millennia, and you cannot last only on faith. You have to have science, you have to have technology, you have to have innovations. And all that is needed for a civilization to work, especially when it is going to work over several millennia. And so we'll talk about all these issues as we go through today. And the first thing that I want to do is talk about origins of science. Now, generally, if you look at popular science books about origin, you would think that science only begins when Galileo goes on Tower of Pisa and throws a feather and a stone and sees which one reaches first. And that's how science began. And that is nowhere near the truth. That is just one of, first of all, he could not have done that experiment simply because the feather would have drifted in the air. It was not an ideal condition for doing the experiment. But anyway, those things apart, science essentially is far more fundamental. So science is an objective study of how nature works and try to get and understand, or try to get nature to do what we want to do. Studying how nature works is science. Studying getting nature to do what we want it to do is essentially technology. So they are twins, and I'm going to use those two phrases interchangeably. The science actually begins when the first human comprehended his life beyond just survival, and he realized that he can enhance his ability to hunt, etc., provided he or she can use the material around it, and not only just material around it, but also be able to shape it in a way that he can use it. So take a sharp stone and use it once is something many animals do. But the idea of making a sharp tool by breaking stone in a particular manner is what science and technology are about. And then it becomes a continuous dialogue as time proceeds. We start worrying about how does nature work. So we actually do actively intervene. We actually do experiments. We actually try to say that, okay, I think this is how nature works. Does it really work like that? You check it, and nature tells you that yes, it does or it does not. And then you try to find out why it does not. And if it does work like this, can we get even further insights into why it works the way it does? And that is what science is about. It's a continuing dialogue between nature and the person who is inquiring about how nature works. Like I said, science did not start in the 16th century in Europe. It was just one of the many, many landmarks that we call science today. Science inquiry began, like I said, when the first human appreciated the consistency of the working of nature and the reproducibility of results, and then started experimenting with nature to try and find out how nature works. All cultures, all civilizations have contributed to it depending on its capability and its environment. In countries like India, where the weather does not really get to extremes, survivability in environment was not a serious problem. And so we did not focus on those issues. In Europe, survivability in winter was a major issue. So they focused on those issues. So there are issues in which each culture will sort of react to what it needs, decides on what it needs, and work on what it needs. And each culture will depend on its capabilities, its environment, its traditions, and so on, in order to make a deeper and deeper understanding of science. But that is not what we are going to talk. We are not going to make a general discussion about evolution of science in general. We are going to be very specific about talking about India's contribution to this great enterprise of science, because there are a lot of misunderstanding. A lot of us feel sort of inhibited that science is something that is in Europe and we have to learn it as an artificial learning thing because it's a useful thing to have. And that is not true. India has had a very rich and great traditions in science. There are some things we got, there are some things we did not get, there are some things that were completely unknown, which we had to create from scratch, on which others build later on and all that. That's a different part of the story. But the fact remains that there have been some significant contributions. And we'll look at some of these contributions and then worry about how those contributions themselves are so significant and magnificent that we really do not need to make false claims. And when you start making false claims that we knew quantum mechanics or we knew something else, you sort of undervalue your own genuine creations. People will not look at even your genuine claims of originality and creativity, because they will always think that you're crazy trying to claim that modern science is was known to people 1,000 years ago. It diminishes you. It does not do you any good, and it makes you a laughing stock. So let us understand what we know, or what we discovered, and we should be proud of what we did, because these things were not known at the time when people were wondering about how nature works, and that was an outstanding achievement. And we'll talk about each of these. So there are, first of all, important landmarks in science in general. Tools are something that not just humans use. Humans use, birds use, animals use, a lot of them use. But the thing is that what humans do is that we use it in a general and versatile manner, which is what distinguishes humans from us. And even archaic humans, 1,000,000 years ago, not just Homo sapiens sapiens, knew how to use tools and how to fashion tools and how to make sure that you sort of get maximum out of your environment for survivability. So flake tools are as much as 500,000 years old. And early humanoids actually made tools as much as 2 million years ago. So there is evidence even in the subcontinent. In Chennai, we have found human-made or Homo sapien-made tools which go back to 1.8 million years. And these are not Homo sapiens sapiens. They are not the people, humans, tree from which we... So they are not humans in the sense that we are. They were archaic humans. Their brains were slightly smaller, but they were certainly biped. They walked on their feet and stuff like that. But their brains... composition was different. The different lobes were different, but they were. But even then, so these people also at 2 million years ago, like I said, 1.8 million year old tools have been found where they made huge stone tools to cut open animal skins or even hunt for animals and so on. Anatomically, modern humans, as we know that Homo sapiens sapiens, arrive about 200,000 years ago. And it takes them 150,000 years before they fully understand their brain and their capabilities. Even now, for example, our body is not fully adjusted to vertical standing, and we need to sit down. A lot of us have spine problems and so on, because that problem of handling the center of gravity is something that continues to trouble the biped humans. So humans spread across Africa almost soon after they were born. So we believe the earliest humans were somewhere in Ethiopia, and then they very quickly spread all over Africa. By about 200,000 years, they are all over Africa. The first human-made bed, in the sense that a pile of twigs and collections of plants, loose plants, which would have made a fairly small, so a comfortable ambit of roughly human width, is found 200,000 years ago. The oldest bed that we know of humans having used is about 200,000 years ago. Similarly, the oldest jewelry we know, where shells we have found shells with artificially made holes in them, and those jewelries date back to 135,000 years ago. The controlled fire, the earliest example we have of burnt charcoal in a controlled fire is about 125,000 years ago. The language, the earliest complicated coordinated use of sounds in order to convey a larger organization seems to, with a proper grammar and all, seems to date back to as much as 100,000 years ago. Humans begin migrating out of Africa about 100,000 to 70,000 years ago, and then they very quickly spread across all the continents. The earliest use of clothes, for example, by humans, by the time they came out of Africa, they would have realized that the winters can become chilly, and that they would start using coverings in order to protect themselves from the cold and so on, comes about 70,000 years ago. The oldest traps that we know to catch small animals like rabbits and so on seem to date back to as much as 70,000 years ago. And these are, remember, great profound developments in science and technology for the time period we are talking about. Controlled fire was certainly no joke, because creating that fire and controlling that fire is not an easy exercise at all. Bow and arrow surprisingly come as early as 64,000 years ago. People who were in an environment where bamboo was being made realized the elasticity of that bamboo, and realized that if you keep it bent, then some certain amount of potential energy is stored in it, which can be used to throw a projectile far away, is a development of great intellectual creativity. And that comes as early as 64,000 years ago. All these are major landmarks in science and technology. Later as humans spread out of Africa, they became behaviorally more modern, and now different developments are seen in different parts of the world by the time you come to about 50,000 years ago. There's a certain rise in creativity as humans move out and encounter new environment. We see the earliest use of musical instruments in Spain, Germany, and Northern Africa that dates back to about 40,000 years ago. The earlier use of rock art is around this old. The earliest female figurines where people have traced out images like these are typically a few centimeters in size. People have argued whether it is Mother Earth or whether it is simply for other purposes. We really do not know. But these are as much as 35,000 years ago. The oldest pottery is 25,000 years ago, 20,000 years ago. Remember that it is not easy to look at a patch of mud and say that, wait a minute, I can shape it into something like a bowl so that I can use it for storing material. All these are major intellectual creative actions. So constellations, for example, the earliest evidence we have of people having drawn constellations are in a cave in France, dated to 15,000 years ago. Then a major developmental phase comes around 12,000 years ago when farming becomes central to humans. So about 12,000 years ago, we start seeing farming. In Central Asia, we see metallurgy, the first use of sort of burning soil so that you remove all the garbage and get a very hard piece of material which we can use, comes about 10,000 years ago. Writing was invented about 8,000 years ago in Mesopotamia, the earliest example that we have. Wheel and related technologies come around 5,000 years ago. Horse comes around 4,000 years ago in Central Asia, coming from America and so on. But these phases, I mean, when I say 5,000 years ago, obviously there's a certain error to it and there is a certain turnaround to it. Also, this is the most recent evidence we have. Alchemy is essentially a part of metallurgy. Somebody asked me in the group chat whether, so let me look at the entire question. Would it be right that Isaac Newton was not exactly the pure science in that that he was trying to prove existence of God? I do not want to get into individual because Newton had his own set of compulsions. He was also, I mean, really, for example, early journals of science are actually called Science Journal of Philosophy rather than Science. So, and then it becomes physical philosophy and all that. So I really do not want to get into individual scientists. I want to look at the broader picture and certainly not talk about Western scientists or European scientists. So these are certainly the broad set of features. Compared to that, humans are domesticated about 5,000 or 6,000 years ago in Central Asia. They are originally American animals that come via Alaska into Central Asia, and then they are domesticated. Bronze and copper becomes regularly used by about 5,000 years ago in India. So Harappan civilization, for example, was excellent with copper and bronze. Pyramids were built about 4,500 years ago. Harappan cities start rising about 4,500 years ago. First major religious text that has survived the Rigveda is about 4,000 years ago, between 3,500 to 4,000 years ago. Avesta is probably slightly older, but there is no really full text of Avesta available. Mahabharata is about 3,300 years ago. Iron comes to Central Asia and to India about 3,300 years ago. Greek civilization peaked around 3,000 years ago. So they're 1,000 years after the Harappan civilization. Persian transcontinental kingdoms that spanned across the entire Central Asia from Hindu Kush mountains all the way into Turkey and beyond, it was about 2,500 years ago. And then the Europeans come as a matter of revenge, and they also come, Alexander, etc., come all the way to India. Vikram Samvat, the earliest calendar that has been continuing, comes 2072 years ago. That is 58 BC when Vikram Samvat is started. Shaka calendar, which is also used at many places, comes when in South India it is decided that 78 AD they would start their own calendar. Ghazni invaded India about 1,000 years ago. European expansion with their guns, germs, and steel began about 500 years ago. Babur comes to India about 500 years ago. Taj Mahal is 400 years old. Telescope is 400 years old. Aircrafts are just 100 years old. And I was, of course, born 66 years ago. So there's a degree of continuity. Nothing was dramatic. Everything is gradually increased, building up on the previous knowledge and so on. And that is how the world of science has evolved. Okay. The early sciences, most of the progress was actually made in Asia. Asia, that is including Central Asia and the Indian subcontinent. So, culture near Palestine, near Euphrates and Tigris in present-day Iraq, Persia and India were all very active, and all the way up to Egypt. So, from Egypt to the Indian subcontinent, or it is the western part of Indian subcontinent, was a very active region where a lot of developments occurred in science and technology. And we'll look at some of these issues as we go about. Mesopotamian culture in Tigris and Euphrates, near present-day Iran, flourished around 3,100 BC, slightly ahead of ours. They were urbanized, they had farming, their work in astronomy and arithmetic was excellent. They actually had base 60 rather than base 10 that we normally have. Base 10 comes from the 10 fingers. We have base 60 is a fairly sophisticated thing because base 60 is the smallest number that can be divided by a whole bunch of numbers: 2, 3, 4, 5, 6, 10, 20, and 30. So in trading terms, it was easier to use this base 60, and therefore trading was done in base 60 and not in base 10. And that was more than 3,000 BC, 5,000 years ago. Indian urbanization actually starts by around 2,700 BC when Harappan civilization comes up. It was contemporaneous to Egypt's and Central Asians, and all of them peaked around the same time, and all of them vanished around the same time. For almost 2,000 years, from 600 BC till 1600 AD, India was one of the most significant centers of learning. And I will come to this point again and again. There's somebody who has a chat question. So India declined by about the 14th or 15th century. What happens is that India gets disintegrated. The centralized kingdoms are lost. There are a lot of little kingdoms, none of them having the economic strength to maintain developments in science and technology. And by that time, the Arabs have come out very well. And so they sent emissaries everywhere. Alburoni's India is a very famous example of that, where they go and accumulate knowledge. And one of the greatest things about Arabs were that they were very good at documenting. They wrote down honestly with great integrity everything that they learned from the other cultures and then added their own. So they would take arithmetic and number systems and the basics of algebra from India that had been developed in 500 AD. But the word algebra itself is an Arab word called algebra, and it comes because Arabs actually develop a whole bunch of ideas of algebra. But they actually note that some of these things come from India, some of these come from Egypt, some of these come from various cultures that they encounter, even from Europe. Early European data, for example, when Europe comes out of its dark ages in 15th or 16th AD, they really do not know what Aristotle and Plato and others had done. They find it out from Arab records. And that is one of the great contributions of Arab scientists that has never been fully appreciated or acknowledged. So this is how these are the urban phases of civilizations. civilization starts all the way 3500 BC and dies about 550 BC. Similarly, Egyptian civilization. Harappan civilization 2500, by about 1500 civilization are dead. But by that time, Vedic culture becomes the great development of India, and it goes on. So there's a degree of continuity till about 1200 AD, and then we get into trouble. China starts a little later than us, 2000 BC to 1500 AD. Then there are other civilizations that come over a period of time. Science and technology and war. So let us, amongst all these stories about various cultures, let us focus on what India was good at, because that is what we have come here to discuss today. So it can be divided into three major periods. The first is the early period, prior to 1000 BC. Harappan civilization and its technology are a marvel that have to be seen to be believed. Their water management system in towns like Dholavira, for example, were so good that from the city itself, they made sure that the used water, the dirty water, is separately stored. The fresh water that is delivered has a certain proper way of doing it, and the dirty water should not go back and contaminate the drinking water that they had stored. Dholavira, for example, is in a desert. The rains would be rare, so they had huge lakes, interconnected lakes, so that when the seasonal river came, it would fill up one lake after another. All the 16 lakes would be filled, and then they would have water enough for 2-3 years. But that water had to remain purified, so the dirty city water would go somewhere else, which is better than what Mumbai city does right now, for example. So Harappan civilization and their magnificent cities, orthogonal planning, a whole bunch of technological developments went into Harappan civilization. Unfortunately, their written records are small and not fully read, so we essentially have to look at archaeological evidence to understand how sophisticated they were. Squaring the circle. So one of the problems that Vedic people come across when they come to India, when they start with Havans, is that they want to assign Havans, Vedis of different shape to different gods. Some have square, some have semicircle, and so on. And in order that the gods are not unhappy, they would want to make sure that each Vedi has the same area, and therefore the volume. And so they went to elaborate lengths to try and find out about how to square a circle. How do you make a circle or a semicircle of the same area as a square? And the entire basic foundation of early Indian mathematics comes from this idea of trying to squaring a circle. They come across pi very quickly, realize that it is not rational. They come out with various approximations methods, they've come out with various geometric construction structures and so on. And there's quite an impressive amount of shapes and designs and all that goes into that period. Sulba Sutra, actually 1000 BC, formalized this, and they are sufficiently good to realize the Pythagorean triplets. They don't give a formal proof because that concept did not exist, but they definitely knew about the Pythagorean triplets, where a square plus b square equal to c square in a right angle triangle. Number systems, we do have powers of 10 imagined in Vedic system itself. So there are things like, may you have 10⁻⁷ cows and stuff like that. Those things don't require, because they were oral tradition, you obviously did not require 0 to be explicitly written. In the sense that if you say that I have 2017 cows, it is 2017, but you don't need to explicitly say that 0. So the numeric representation of 0 is a different issue, but the idea of large numbers and powers and exponents actually exists in Vedic literature itself. Mahabharata itself is a technological marvel in many ways, in terms of war technologies, war understandings, even governance and so on. It is a proper constitution about what are the rights and duties of the kings and how much tax they can collect and how they should use this tax, etc. This is a lot of it going on there. For example, through the criticism of Duryodhan, never is it said that his people were not well administered. And whatever the Kauravas and Pandavas did, the praja of Kauravas never rose against them. So there was a great sense of administration. There was a great sense of how to look after people, even as early as 1500 BC. Um, then there is a golden period that India comes across, that is 1000 BC to 200 AD, largely in the Gangetic plain. So there are various developments. There is a Vedic period, there is a Gnostic period, and then there are free developments in the Iron Age. So Panini's grammar comes into being 6th and 4th century, between 6th and 4th century BC, which exhaustively formulates the grammar of Sanskrit. And that is by far one of the most well-defined grammars in the world. It is better than even, English has this Wren and Martin. This was far superior in the sense of complexity because the language itself was complex. Sanskrit was an orally transmitted language, and therefore, because of the original transmission, it meant that you had to make sure that you pronounced everything correctly. And in order to pronounce everything correctly, it was not just a question of whim or shortcomings of a particular teacher that would sort of, for example, spoil the language transmission. So there were 6 internally bound rules which decided to which ensured that the transmission of oral languages continue. So we have this, we have as a language itself, it is the only language class in the world where the vowels and consonants are mixed in a particular way. The sandhis are used in a particular manner. The numeric system coding there are 2 or 3 styles which were used in various manners, so that you could code number which apparently look like poetry until you actually used it and figured it out. A whole bunch of complex developments in linguistics and computational linguistics, as well as information coding, actually happens at that time. Universities of Takshashila and Nalanda come up. Takshashila is 8th century BC to 6th century AD. Nalanda is 5th century BC to 13th century AD. 1800 years Nalanda ruled, was the core of education in India. And for 6 and to 800 years, Takshila was the center of learning in the world. Compared to that, Mumbai University is 130 years old. There are 3 very famous sets of books that come up during this time. The first is Nyaya and Vaisheshika systems. Nyaya, Vaisheshika, I will talk about a little more because it's a beautiful book. It's the first genuinely secular book of science, 2nd century BC. Century BC. It does not invoke God. It does not have prayers. It does not have worship. It simply tries to explain how the physical world works. And I'll come to that in a minute. Nyaya investigates logic. What is logical thinking? What are the ideas of logical thinking, and so on. And Vaisheshika, for example, I will show you, defines for the first time objective knowledge and causality and so on. Vaisheshika is concerned with the nature and source and limits of knowledge, and we will discuss that in detail just now. Yoga and Sankhya are methods of medicine. Yoga is, of course, in various evolved forms, is still a very revered way of learning. But essentially, yoga is not just a question of exercising and training your body for fitness. There is meditation is a part of that. So the idea is to get into a kind of resonance with God, your personal God, Ishwar God. It is not the great gods of the Rigveda. This is Ishwara is your private God, and the idea is to get into a resonance with your private God. So yoga in its original form actually goes way beyond what we now do as exercise or yoga. By the way, it's a very small component of the actual work of yoga. Similarly, Sankhya investigates what it is to exist, to becoming, what is reality, what is not reality, and a whole bunch of ideas. And when we talk about Indian logic system, we'll come back to briefly mentioning this. Mimamsa and Vedanta are the third pair of books among the great series. Mimamsa investigates the nature of dharma in the sense of duty, what it is to live in a culture, what it is to live in a society, what are the things that we should be doing, and what are the moral laws we should be following. It is not dharma in the sense of religion, of worship of a particular god. It is a question of morality of living in the society. And then Vedanta, of course, investigates the ultimate physical reality of the great God and Brahman and so on. So these are 6 very classical books which continue to resonate even today. This is Vaisheshika. This is what I like about Vaisheshika. It says it's a completely secular book. There is no God anywhere. And unfortunately, there is a lot of secular literature in Sanskrit which has been ignored for various reasons, mostly for lack of translations. So it says material universe consists of matter and material. And then material has dravya, and that consists of the five Panch Mahabhut, the solid, liquid, gas, sky, and energy. Then there are active entities, kala and dika, space and time. And then there are two life forces, mana and atma. So they probably first saw life in plants and everywhere, and they probably came out with this conscious that there are the things that self-grow have atma, they have consciousness and know how to grow. So they have an atma. But then they realize that clearly animals are more than simply atma. So they come out with the second concept of mana, which is what distinguishes animals from plants, for example. Then each of these things have guna, properties. And those properties include color, taste, odor, touch, number, measure, and a whole bunch of things. There are also in other things like happiness, unhappiness, desire, aversion, effort, heaviness, the weight, fluidity, oiliness, elasticity, and a whole bunch of physical properties. But for the living, there is also this intellect, happiness, and unhappiness parameters, and desire also. Then there is karma, things that happen. So you move up, you move down, you contract, you expand depending on heat and so on, and there is displacement. These are the basic things that happen to you. And then there are vishesha, specific properties of each entity. Color is one, shape is another, hardness is another, and so on, which are vishesh to a particular object. These are generalized properties. And then there is inheritance. You inherit some properties from the way you were before you became the current shape. Again, this is for the entire physical universe and not just for human beings or just for the living. And then there is samanya, common properties, unlike the vishesha. Samanya, this thing is everything exists, everything is transient, and there is cause and effect. And this we really do not appreciate, but is a major development. For the first time, Vaisheshika is the first book of learning that insists on causality. If there is an effect, there must be a cause. And that cause is not intervention by God. That cause is because of the way the physical universe is. So that is how the book runs. Just to give you an idea about what the general structure is, I already told you broadly the general structure. But for example, this is the physical manifestation of matter, the Panch Mahabhuts, solid, liquid, gas, sky, and energy. These are the life forces, Atma and Mana. These are the emotional points which are a part of the story. Then there is motion and movement and displacement and so on. Then there is quantifiables, color, taste, touch, even fluidity, heaviness, and so on. And then there are physical properties of an entity, fluidity, oiliness, elasticity, and so on. Then there is chemistry, distinctiveness, conjunction, and so on. And at the end, there is this activity here, which I've forgotten to mark, which is kala and dika. Kala is time. So there is 3 dimensions of dika and 1 dimension of time. Eventually, of course, unfortunately, what it does not do is it does not quantify. And why does it not quantify and all that is something that we'll come to later. But Vaisheshika is such a wonderful book that for 1,000 years, it held as the center of creativity and understanding physical universe across the known world. So even there are Chinese version of Panch Mahabhut and all that come from this basic analysis of how nature works. There are rules of reading Vaisheshika. There is causality. It says if there is an effect, there must be a cause, and that cause must be a physical cause. God came and did it kind of thing, arguments don't work. And that is the basic foundation of science, for formal sciences. Okay. And it also explicitly demands that cause must precede the effect. And there is no effect in the absence of a cause. That you have, if something has happened, you have to find out why it happened, because it has happened. It also divides the properties into dravyas, gunas, and padartha. And dravya can neither be created nor be destroyed by physical action. So karma cannot destroy dravya. Gunas, on the other, are properties that are destroyed by cause and effect. If you heat up something solid, it becomes liquid and so on. Motion is an act of karma. Karma in the sense of activity. And karma can only be opposed by karma. You cannot stop motion of something without actually working against that motion. The change in guna is a result of karma. So heaviness can change, fluidity can change, etc. So if you want to look at, for example, how did fire happen? Then fire happens because earth and liquid get energy of fire, and as a result of conjunction, which conjunction happens, and gas gets released and energy gets released. So to a person who says, okay, fire is strange, how does it work? So there's a formal framework under which you understand how fire works. And then eventually you get odor also from that fire, and you can feel the temperature or the heat of that fire. And so on. So one can go on and on using various physical examples to see how they are best explained by how they best explain the physical universe and what is happening to you around you in a purely objective manner. They also talk about Anu and Parmanu and so on, but those are slightly different from the physical Anu and Parmanu of periodic table. So Anu is only of one kind, and that is the ultimate smallest object in the universe. So they actually argue saying that, look, matter cannot be infinitely smooth, because then you can take a piece of stone and keep cutting it until so much of material comes out of it that you can make a mountain out of it. You can't. So somewhere there is a contradiction in that idea, and somewhere if you keep chopping material, it must stop. And that smallest object he calls Anu. But that Anu has no properties and it has no physical existence and it's pointless and so on. So the idea of calling the present atomic structure as Anu is a 20th century extension. In the original Vaisheshika, that idea is not there. The idea of Anu is very different in Vaisheshika. So then after that, you have a set of major development in the Siddhantic period where science is formalized. You have formulation of astronomical problems in mathematics. First, trigonometry comes into the sky, because the sky moves. Movement of stars in the sky, etc., is better explained by trigonometric functions rather than linear functions and so on. So invention of trigonometry comes. The first formal algebra of zero comes. Now, zero itself is used much earlier than in India. In Mesopotamia, people use zero as a numeric system. But the reason why India gets credit for it is so that for the first time we give a formal algebra of zero. What happens when you divide by zero? What happens when you multiply by zero? What happens when you add zero? When you subtract zero, and so on. And even exponents of zero and things like that. Then, of course, Kerala school has its own flavor, which goes on well up to 16th century. Modern period would probably start with Taj Mahal because of its sheer architectural magnificence, which could not have arisen without significant amount of science and technology behind it. Unfortunately, the documentation left behind is not very good, and it was largely not considered a great intellectual activity to document things at that time. So a lot of that science has been lost. Tipu Sultan's rockets, which almost defeated the British, and the British were so scared of Tipu Sultan's rocket that eventually when he died, they took his armor and it was on display in England until well within this century, when the popular movement shamed British king into removing it. But they still hold it with pride that they managed to kill Tipu Sultan because his rockets and his weapons technology was phenomenal. Whatever you may say about other things about Tipu Sultan, the fact remains that he was a great warrior. Developments in mining and metallurgy, the wood, steel, zinc, and so on are essentially Indian technologies which would eventually go on to change metallurgy. The other way of achievements in textiles, warfare, art, literature, which I don't even have time to go into. So there are some great developments. One of the most sort of consciously famous invention for which you are very famous is zero. You can keep on arguing whether it is discovery or invention, but it is attributed to India, like I said, even though Sumerians were the first ones to use it. And then there is a lot of profound part to zero. Zero is something, for example, that Europe abhors. And the reason why Indians were comfortable with zero is that there was a contextual development. The idea of null existed in the philosophical space well before it became an algebraic issue. Remember that even to the ancient Indian mathematicians, mathematics was a language. It was not a tool of science. And it is really very discouraging to see that mathematics is now projected simply as a tool of science. But even then, mathematics is the only subject where even today you can do BA and BSc. And that is because mathematics is a language as well as a tool. And early Indians used it as a language. So in that language development, the idea of zero is something that they understood which is phenomenal. So they had, but that is because there was background idea of nullness which evolved everywhere. Which, for example, in Europe, and I will come to that a little later, the idea of null did not exist. The God existed everywhere. He was omnipresent. And therefore, even if you removed everything from some place, the God always remained. So there was always a singularity. There was never null. And therefore, they were uncomfortable with the idea of zero when they came across it in arithmetic, and especially when they went beyond arithmetic. So, for example, even Roman numerals, IV, XL, CDM, don't have zero. And they always were uncomfortable with zero. On the other hand, Indians were so comfortable with the idea of null and the God being undefinable null, is that they went on with this idea quite comfortably. So first idea is in religion. If you look at things like Nasadiya Sukta and all that, there's a very clear idea that in the beginning, nothing existed. And that nothingness is an idea that sticks to Indians all through. Indians use zero for grammar. Panini, for example, say that, look, if you want to make this language of spoken language rigorous, then you have to have sandhis. And sandhi means that some sounds will go away, some sounds will get added, and so on and so on. And therefore, you will have to have null, filling in two different words, part of which will be nulled. And then it was continued. I don't have time to go into the exam details of this, but for example, if you have a name like in Maharashtra, which is very common, where if you have a name like Vategaonkar, it means Vatet Yenara Gavat Rahnara. And a whole bunch of words in between are mixed and deleted and so on to make that Vategaonkar. And that complexity comes from Panini. And in fact, Panini himself says that I'm simply being encyclopedic in compiling all the ideas. The ideas come from earlier generation. So that idea of null and non-existence is something very common to Indian philosophers. And therefore, in 5th century, when people start worrying about zero now in the language of mathematics, they're completely comfortable with it. And therefore, the algebra of zero comes from India in 5th century AD. There's a lot of work done as to why Europeans struggled with this. And it is quite funny that even though India gives algebra of zero in 5th century AD and the Arabs very quickly pick it up as a beautiful mathematical systems, Europeans will not accept it till 14th or 15th century AD because the idea made them nervous. Indians demonstrated that it is a powerful concept and a powerful entity. See, mathematics eventually in Europe completely accepts zero when they come out with a set theoretical representation of number systems. And that is when they say that a set with zero as an element is different from a null set. And that is when the idea of zero strikes them hard. But before that, for various algebraic purposes, the traders and the others would have wanted to use it, but the Pope just would not allow it. And eventually in 14th century, a lot of effort was made by mathematicians to force the Pope to accept zero, and that is when zero got accepted. Zero is very late in Europe. European accepted zero, like I said, for 900 years later. And we will come to these differences a little. They extended this to physics and the other fields of science. That is something which we did not do. In India, zero was a beautiful entity, but mathematics was just a language in which great intellectuals spoke and talked about various theorems and algorithms. The formal concept of proof was not there and so on. So it was purely handled as a language, not as a tool of science. The Europeans would use it as a tool of science and go further. So India, as India went into degeneration and disintegration and decline around 12th or 13th century AD, our knowledge was taken up by Arab scientists. Alburoni, having come to India, documented all the Indian ideas and creativities and taken them to Arab is a beautiful example. If Alburoni is now, India is now available in English, and you should read how methodically and systematically Alburoni worked in order to gather all the knowledge. And then he eventually actually very tragically and very prophetically says that, look, Indians have been great at all this learning, etc. But eventually their xenophobia is going to take them down. And sure enough, in 100 years, that xenophobia would eventually self-limit Indian science. It was eventually passed on to Europeans. Europeans through the Arabs, and then Arabs. But Arabs, so for example, 1, 2, 3, 4, 5, 6 are called Arabic numerals in Europe, but Arabs themselves are very clear in documenting, saying that we have learned them from India. They have been remarkably honest in their endeavor. But there are very fundamental differences in thinking between India and other parts of the world. So, for example, there is a theory of knowledge. Today, if you look up a book and say, what is the theory of knowledge? What are the foundations about how knowledge is acquired? It tells you that sense perception, reason, emotion, faith, imagination, intuition, memory, and language are all legitimate ways of getting knowledge. On the other hand, Vaisheshika itself defines what is knowledge. And he says the way of acquiring knowledge is through perception, pratyakshas, to see what is happening. Inference, based on what you have seen, anumana. Analogy, upamana, comparison with what you have seen. Derivation from circumstances, artha prapti. Non-perception of negative or cognitive proof. So something has not happened, and you notice that it has not happened. And verbal testimony of reliable persons. And you immediately realize that he completely removes emotion. He just does not include, he does not remove, of course, he is much earlier, he is the leader. He doesn't consider emotion, faith, imagination, or intuition as a way of acquiring knowledge. It's a very, very scientific way of acquiring knowledge. What is knowledge onwards, Vaisheshika defines, 200 BC. Okay. So, and essentially, there are within this the first ideas of experimentation and so on, because there is this idea of pratyaksha and anumana and so anumana and other ideas which are crucial eventually to development of things. But there's a very profoundly important thing over here, which is that this allows for inductive thinking. And I will come to the difference between inductive and deductive thinking, but that guides Indian thinking to inductive thinking rather than deductive thinking. And that makes a lot of difference in later sciences. So India and the West, there are at least 7 different ways between the India and the West that may explain the differences, our response to zero and to other ideas. There's a tradition of worship. In Europe, there's tradition of worship of the great one who cannot be defined, and Christ himself is the Son of God and so on. And there are these beautiful Greek stories about the heavens, almost similar in their philosophy to Indian stories. Then there is disposal of mortal remains. So Indians don't require permanent memorials. Europeans still go after permanent memorials. Indians could, everything came from null, went back to the null. So you simply sort of cremated your dead and moved on in life. In fact, there are various respect for the elders then is also there because some very respectable person has died. So there are this common memorial, there are this Shraddha Paksha, etc., where you sort of worship all your ancestors together and stuff like that. Unlike Christianity, where there is, where now Christianity also allows cremation, but for a long time, graves were the big thing. There is also a tradition of oral transmission of India, which created a whole bunch of creative ideas. Panini's grammar is one of them. And because oral transmission required precision, there are, various. So there are, for example, shlokas in many of the rituals where the words don't make a sense. There is no sound or there is no meaning on that verse. They simply recite it as a matter of musical completeness so that memory is aided and the memory transmission of information is smooth. And that is remarkable. Definition of what is knowable is something where we differ. So in India, the idea of knowable is somewhat amorphous compared to the deductive logic of Western sciences. Then meditative rather than argumentative approach is what would mark Indian approach to science compared to European approach, which was essentially hands-on and experimental. Then prediction of inductive and deductive thinking, and I'll come to that a little later because that makes an interesting difference. So there is a difference in inductive and deductive logic. So in India, in Europe, you would say there's a universal premise that all humans are mortals. Mayank is a human, so Mayank is mortal. Compared to that, Indian logic would be slightly different. It says there is fire on the hill. For example, there is fire on the hill because there is smoke on the hill. And we know that in the kitchen, if there is smoke, there is fire. And it is not there on the lake, but it is there in the kitchen. And therefore, smoke is like we saw what we see in the kitchen, and therefore there is fire in the kitchen. To compare the same thing slightly differently, so the first example about death, etc., I have got it mixed up. So the fire example in deductive method would say fire produces smoke, there is smoke on the hill and there is fire. So it is more direct. While in inductive logic, it is more comparative. Similarly, about death, etc., it says all humans are mortal is the first thing that you would say. Then you would say death is inevitable because you see it everywhere, but it doesn't happen in stones. And therefore, only living die. And for example, my relative who is a living thing died, and since I am a living thing, I will also die. So there is a difference in inductive and deductive logic. It becomes very clear in a few moments. So in inductive logic, a positive example establishes the connectivity between two terms and two events. There is smoke in the kitchen, there is fire in the kitchen, and negative example denies that it is not this. Both positives and negatives are denied. And so lake is not a fire, and therefore what you see on the terrace is not lake, but you see actually a fire. The reasoning does not proceed from particular to particular. So statement A, B, C are true, so the common thread must be true is not what is done. It is always inductive. Deductive logic, on the other hand, is more powerful. If A is true, and in all cases where A applies, B must follow. And so very early Greeks separate mythos and logos, the logical things and the mythological things. And therefore they go on to this deductive side of thinking. As a result of, there is an important difference as well as formal discrepancy between deductive and inductive methods, and the knowledge that they produce is different. The Greeks also considered this and were overwhelmed by Aristotle, who essentially hated the idea of nothingness, and he would single-handedly prevent this from being used. So for example, the most simplest example that I can give you about the difference in deductive and inductive logic is these two great scientists. Paul is a very classically deductive scientist. He says, my equations are more important than me. It is more important to get beauty in one's equation, symmetry and so on, than have it to agree with experiments. Agreements must follow. It is the equation that is absolute. What is deducted through mathematical techniques is absolute, and my equations are smarter than me. On the other hand, Feynman is very clear. He says, I worship the phenomena and not the explanation. To me, phenomena are beautiful, and I think this is how they were. I don't tell nature what to do. Nature tells me what it is doing. And a great deal more of truth can become knowable than provable. I mean, you almost feel a shadow of Gödel's incompleteness theorem in some sense of the word, except, of course, it is not rigorous. So the difference in deductive logic, just to repeat, is Paul Dirac. He says, my equations have to be beautiful, symmetrical, etc., because nature works by symmetry. And I know that from my previous experience. And therefore, my equations, once I've derived them, are more smarter than me and are independent of me. Feynman says nothing doing. Feynman says, worship what you see is what you try to understand. Don't try to tell nature that, look, this is how electron should become a positron or something. Well, electron can't become a positron, but anyway. And therefore, he believes that a great deal more of truth can be known, but not proven. And then Bertrand Russell beautifully puts it as a symmetry. He says deductive logic never produced anything interesting, whereas inductive logic does. And this difference is even in 21st century. So even today, for example, so there are European or American scientists who would choose an Indian student if the work that required argumentative work and thinking and sort of instinctively picking up new understanding rather than pure mechanical work, because Indian students are much better at those kind of things. So there are some general comments. The rational and intuitive are not diverse. I'm running way back, way slow. Rational and intuitive were not divorced in India as they were in the West, and hence the disparate logic of could develop in India. So we had this contrasting. Nar and Nareshwar, for example, is a very common idea in India. It would not exist in Europe. Relative non-open-mindedness of India, on the other hand, would eventually relative open-mindedness, for example, allowed you to understand zero as a language, even in mathematics. The West adopted zero functionally eventually when they were forced to in 16th century, 14th century, but they still remain hesitant. This awkward state continues even today. For example, frankly, the black holes are 0 points, and yet they are called singularities. Um, One can similarly, there is a mirror argument about infinities, etc., which again the Europeans hated and the Indians loved. But I really do not have time. I'm already running late. But you can, before I go to the shortcomings of Indian science, I just want to make it that you can ask an interesting question, whether inductive approach can give you the same science that deductive approach is given. I'm not so sure of the answer at all, but I have my own doubts. Aryabhatta accepted the rules of planetary motion, for example, but he did not fit it into the 1 upon r square phenomena. That the Greeks did because they were deductive. And say, wait a minute, if this is the phenomenon that I've seen, there must be a deductive algebra behind it, and that's how you get Newton's laws of gravity and so on, which Aryabhatta does not. Aryabhatta simply says that it is a prakriti swabhava of planets to go around. The mathematical rigor was not alien to the Indian thinking, except that it was not converted into physical parameters. And therefore, in the long shot, probably India would not have reached many of these developments that deductive logic would bring. So more or less by 5th century AD, Indian knowledge becomes century. Even Vaishika is beautiful at explaining science or working of nature to people, but it will not on its own lead to creative thinking unless you worry about causality and philosophical ideas. Deductive sciences are now reaching their limit. And they have given us a deep understanding of the basic physical principle of the working of the universe. Quantum mechanics is the only phase where we still are struggling. But a lot of questions remain unanswered. And as Feynman famously said, that you can understand more than you can actually prove. And many are taking inductive approach to learning. Something is, according to me, is happening this way to the best of my knowledge and belief. Simulations are an example of that. Any simulation is only good as the programming. In many ways, experiments done without basis of theory is also an inductive method. And it's worth thinking about it, but it's not something that I want to pursue here. But there are some definite shortcomings of Indian science. The first was that everything was assigned to prakriti swabhava. That is the nature of things. Why do the planets move in that way? There is no GMM by r square. There is just prakriti swabhava of planets to do that. It doesn't take you very far. And therefore, it reaches a plateau. It remains an actual pursuit that is in the pure form. They would not sit with artisans and do that. And therefore, these students avoided sitting with artisans. So a whole bunch of the classical mechanics that Newton and others would do, or even Galileo would do, would be missing from Indian science. Building everything from Harappan cities to Taj Mahal would have required phenomenal amount of understanding of science and technology by the artisans and people who actually did hard work and experimental work. But that is not documented. Because those who were documenting were only interested in mathematics as a language and not in documenting what is happening in reality on the ground. And that is a shortcoming that would hurt us. Social stratification is an obvious reason why that happens. What held Indians back? The problem is what held India back are two categories. One is social, xenophobia. We just hated people who were not like us and therefore never discussed and exchanged ideas with them. The caste systems, where the scholars would not sit with artisans to figure out the physical laws of governing meter-sized nature, is something that cost us dearly. And disintegrating governance structures with multiple mini-kingdoms, etc., means there were no resources at some stage to pursue science and technology. The other part was inductive thinking itself, which essentially develops a comparison and experience. It does not allow the kind of generalization that was needed. So from making pendulum to wristwatch with crystal is based on generalization, which would not have been possible. This led to deriving of mathematical structures that have degree of universality, and isolated deductive mathematics methods would therefore go very far, and Indian science got left behind in some sense of the word. There are some very great limitations. There are four major fields which India completely misses. There is no gravitation, there is no thermodynamics, there is no electromagnetism, and there is no structure of matter. And then there are smaller fields like optics, mechanics, in some sense at that stage, molecular biology, etc. So there are these ideas about diseases in yoga itself, but they do not use a microscope to find the germs and so on. The corresponding technologies, therefore, were not realized. There was no electricity, there was no air or space travel, there was no uncertainty principle, there was no whole bunch of things. While there were general ideas about relation between disease and life forms, absence of microscope meant that several fields were simply left unexplored. But there is much to be proud of, but we don't need to exaggerate. And I'll tell you, I will just discuss some of the exaggeration that is done. So it is fashionable today to make irrational and exaggerated claims about our achievement. Some of these include that we knew uncertainty principle and more. Some of them said that we knew Vimana and interplanetary travel, and people have seen in Mars images two Indian kings fighting on Mars, etc. Genetic engineering, including gender change, etc. we knew has been claimed, and so on. Then trans-animal exchange of organs, etc., has been claimed and all that. And atom bomb in Mahabharata is a very common story. And even internet, not even telephony has been claimed because Mahabharata story is told far away from the actual war. And the list goes on. And this is dangerous. Some of these claims are without demonstrable capabilities to achieve something of this magnitude is simply dangerous. It gives the nation a bad name and makes us a laughing stock. China had somebody called Needham, a European scholar, who went there and for several decades actually shifted out what was good, acceptable technological development of the Chinese and what was just fairy tales. We probably need somebody like Needham to actually sit and see what are genuine technologies and what were not. But falsifying claims is what I want to talk about. If you go and tell somebody that the claim are false, the standard argument is that you are not present at that time, and how do you know the claim is false? Of course, I did not live 100 years ago or 1,000 years ago. That is even worse. But that doesn't mean I can't make out what they were thinking, because I can see what they left behind in terms of literature. There are plenty of mythical stories about Ganesha and Shikandi, which should tell you that that organ transplant and trans-animal transplants, etc., are possible. Now, these are fictional stories. They are philosophical stories. Elephants have phenomenal memory and phenomenal capability of recreation that we know. So it is natural to have a god with that kind of infinite capability, and that is how he writes down Ramayana and all that and so on. Shikandi is simply a man of confused gender, a person of confused gender. You are the third argument that is given is that you are underestimating the genius of the rishis because you have been educated in Western style, and therefore you are still slave to their ideology, and you are not patriotic enough. That is again nonsense. And I will show you that rishis were great, profound thinkers. Rigveda is a beautiful piece of literature, but they did not have access to experimental science, and they did not have technologies, and therefore they could not have done that. And if you find nothing else, you simply say that you are a very lousy speaker, we don't understand what you say, therefore you are talking nonsense. And if all else fails, this is obvious. A very standard technique that is used to shut up anybody who questions exaggerated claims of Indian sciences. So let me tell you how to check it. The first thing you should need to understand is that understanding of working of nature is incremental, and science does not grow in isolation. Every idea on how nature works is tested by theoretical works and experiments. Experiments are the final arbiters of all competing ideas of how nature works. Science, therefore, is objective, testable, and it is falsifiable. It is not opinion-based. And falsifiability is a very strong part of the story of science. Wrong ideas, however attractive, are eliminated from science. And if you study history of science, you will see a whole bunch of ideas that look very pretty, but just were not true. That is not how nature worked. So the broad sequence is anatomically modern humans come out 1 million years ago, about 200,000 years ago, they spread all over Africa. Then they spread eventually to the Asian subcontinent, eventually all over the world. They learned farming by 10,000 BC. First cities, 5,000 BC. Indo-Iranian speakers about 4,000 BC, they come to India, 4,000 years ago, I beg your pardon, 2000 BC. And Harappan evidence entirely archaeological, while Vedic evidence entirely textual. We have found really no archaeological evidence of this. And so those problems remain. These timelines are fairly well established now. There is no sense in continuously claiming otherwise. Some examples, people say quantum mechanics was known. Now, to know quantum mechanics, you need to, quantum mechanics arises when people realize that the orbits of electrons around nuclei are electromagnetically unstable because they are accelerated charges, therefore emit their energy, and therefore electrons should sit inside the nucleus. And that doesn't happen. Atoms are very fluffy objects. That is how you realize quantum mechanics. It was a mixture of electromagnetism, thermodynamics, and atomic structure. Neither of these three were known to our ancient races. Merging the two encountered the problem of stability of atoms and laws of quantum mechanics were discovered like that. If the earlier knowledge of electromagnetism, thermodynamics, and atomic structure was not known, you had to have Rutherford scattering experiment, for example, to realize that atoms have nucleus in the middle and the electrons around it. Not a gunny bag model, but a structure that we know. Similarly, aeroplanes required understanding of dynamics, air, wind, and Bernoulli's principle. It needed industrial evolution because it needed internal combustion engine. Even though Bernoulli's principle was known earlier, it needed internal combustion engine to make first heavier than air flying machine. Interplanetary travel required, for God's sake, required understanding of planets, required understanding of heliocentric nature of solar system. Reaching Mars, for example, is like eating a 5 rupee coin 5,000 kilometers away. That is a kind of fineness that you need. You need rockets, you need technologies for that, you need a whole bunch of that, and there is absolutely no evidence of any of that. Extremely powerful engines that could take objects to 11 kilometers per second did not exist at that time. So when you say that 2 of our kings went to Mars and fought, it is just stupid. The mathematical foundation that was required to create this kind of engines and thrust and orbits, etc., just didn't exist at that time. Experimental facilities, test facilities, manufacturing facilities, indeed even manpower group didn't exist. Genetic engineering requires understanding molecular level, life at molecular level. You have to know DNA and DNA structure and its expression, etc. You have to know the centrality of carbon in life when you didn't even know carbon. Double helical structure of life molecules had to be known, which required not just microscope, but it required X-ray diffraction, etc., to figure out the shape. Microscope, etc., and X-ray machines were just not there. And then you needed ability to manipulate these things. Isolated cells in extremely clean and low temperature environment had to be studied and manipulated to create genetic engineering. These things are not known. For knowing atom bombs, you have to know uranium, you have to know uniqueness of atom, you have to know that unstable nuclei can be made to spontaneously decay under forced condition and all that. Atomic fission had to be known, and how to compress a kilogram of uranium into a much smaller volume through other explosives to make it go critical, etc., had to be known, which was not known at all. And even if they had known, we know atom bombs are so heavy that they could not have fitted on bows and arrows. And the radioactivity that would have happened would have left its signature for thousands of years. And there is no such thing. We know in Hiroshima, those signals are not going away. Most importantly, to achieve this, we needed powerful mathematical tools. We needed electricity. We needed a clean environment and appropriate structures. We needed large scientific manpower and elaborate system of education. And they didn't exist. The argument that talk about our past happily mixes time sequence, insists on mathematical knowledge that would come much later into the past rishis. Rishis did not know of Aryabhata's work or trigonometry, for example. So clearly, many of the claims are not tenable. None of these claims are predictive. There has never been a claim that in Rigved claims that this is how you should see, and we have gone and tested in the laboratory to see that it is true. It has always been post facto explanations. If you some chance say something, people go back and say, no, rishis knew something. That makes no sense. Make predictions based on Rigved or whatever Sanskrit literature you want. And there are none. Most importantly, if they had achieved all this, a lot of physical evidence would have been left behind on the ground, and absolutely none exists. Science also does not grow in isolation. So how do you test whether a given claim is correct or not? The first thing you must realize that science does not grow in isolation. It has to be fed with other ideas. So the question is that if some claim is being made, did the rishi have knowledge of the background knowledge, had the background knowledge from which this original idea comes? So for example, to know quantum mechanics, you have to know electromagnetism, thermodynamics, and atomic structure. Were the weaknesses in the idea that they knew were known to them so that they had to explain more, saying that, look, I think atoms look like gunny bags, but it doesn't fit with Rutherford's experiment, so I need to investigate. Did they knew the weaknesses of their ideas? They didn't. Vaishika, for example, has only so much limitation. Does it fit into chronology of evolution ideas? Quantum mechanics get built up on electromagnetism and so on. And so also other examples that I gave. And were they in the position to probe that kind of thing? Did they have the technological capability to do that? Did they have the necessary mathematical skills to do that? If you don't get an answer to all these questions, not any of these questions, all these questions, you can assume that the claim is false. The bottom line is that there is much to be proud of in India's past. We don't need to manufacture stories. Our rishis were profound thinkers for their period, and there's some beautiful poetry and thought and imagination creativity there. We don't really need to make false claims. But the fact remains that they never had this culture of experimental sciences. They were inductive thinkers, they were not deductive thinkers, and they did not have experimental capabilities to back it up. In fact, the first time the idea that experimental back confirmation of knowledge should be done is Arabic idea, 13th century. And then the Europeans, with their deductive logic and this idea of experimentation, they catch up on it and develop the field much further. If the various claims are true, then where is the physical evidence is what you can ask. So let us not make false claims about Indian science predating or preempting modern science. It only hurts our reputation. So by making such false claim, we are only bringing ridicule of ourselves and negating the creativity of genuine achievements of India's past. So it can only harm us. Thank you very much. If you have any questions, you can ask at this stage. If you don't have a question, we
Thank
can
you, ma'am.
Welcome.
One comment.
Okay?
Sorry.
Yeah, any comments, any questions?
You can unmute and ask also, all of you.
One way of claiming many times is the language. Because for any idea, we can construct a word. And then people make claiming that, see, if this word is there, this word is in Sanskrit is there, which means the idea must be there, and which means probably.
Yeah.
This,
so Anu is a beautiful example of that, Mahesh. The idea of Anu is there in Vaishika, but the definition of that word is very different from the current definition of the word Anu. So you are right. Sanskrit words are often mistranslated intentionally, and then for past concepts are claimed. You are right.
And we can give a parallel example then, that like the word computers 100 years ago in astronomy was used for people who were working, doing mathematics. They were computers. So
yes, that is true. Aryabhat is primarily a mathematician, and I mean, I know it's not the main story, but I again want to emphasize that none of the great Indian mathematicians claimed knowledge of astrology. They knew astronomy, but they never used it for astrology. It is an import from Europe to India. Astrology is not an Indian knowledge system at all. I mean, it is fake and all those issues are separate. But no honorable Indian mathematicians of that period supported astrological ideas. They were works of small minds to trap small people.
Another comment about quantum mechanics is, we know now quantum mechanics needs a lot of statistics, and there is no evidence of statistics.
Yes.
There are ideas of permutation combination, but no statistics. In spite of having the Mahabharata having the gambling, no statistics is developed.
There is no statistics. Another thing is that there is no mathematical working called fx equal to 0. 0 points of equations, etc. are not used. That kind of branch of algebra is also not there. But again, you are right. Statistics is not there, not even in its simplest form. You are right. I mean, that points are well made. Any other comment?
Hi, one question. Some of the claims that people say that the Nalanda has a lot of nearly 2 lakhs of books and knowledge, and foreigners destroyed some of the important books they stole, and all these inventions basically belongs to the Nalanda, and they start inventing all this. So these kind of claims, one question. And second question, some of the references of the sculptures that shows us here something. So they say that they know the Bhugol, the earth is round. It's known quite much earlier. These two questions.
So there is knowledge of geography in the sense of knowing oceans are there and land is there and land is surrounded by oceans, etc. But the idea of earth as a sphere on which you are standing on the surface of the sphere is not there, because there is this fear of falling down. And a spinning sphere that makes the earth day, night, etc., is just not there, because Aryabhat, I think, first suggests that maybe just as the Mars are constant and earth is rotating. And somebody else, I think Ramira, makes a lot of fun of him saying, so there are residual ideas, but not the overall information collection. Earth is never converted into a sphere. That happens much later. In fact, the Buddhist cosmogony is completely flat, and they get completely confused with the flatness of this. So they end up inventing 2 suns and 2 moons and stuff like that. So there are various there are glimmers of great ideas somewhere which were not pursued or got lost along the way or whatever. So Vaishika in principle would have, because causality is a major issue there, one could have worked on the algebra of these things, but it is not done. Yeah, before, as Mahesh points out in the chat, Greek idea of globe. Colonization and I don't think the problem is with colonization. By the time the colonizers came, India had completely disintegrated into many kingdoms, none of them with enough resources to really develop science and technology, and they were just busy fighting wars with each other. There were just not enough resources. Kerala school dies because of, I think we should blame our circumstances. And every civilization goes through this rise and fall. It's a sine function everywhere. Yes. Yes. Hey, Mahesh, there are questions in the chat box. Can you look at them?
Yes, sir. There are, I mean, let me go from down top to bottom. There are some questions which were asked right in the beginning. So there is one question about what about Ramayana? You mentioned about Mahabharata's time period. One question is, when was Ramayana?
Ramayana has a degree of ambiguity about it because it is a self-confessed kavya. It is not itihasa. Mahabharata claims to be itihasa. Ramayana claims to be kavya. Second thing is that despite the claim that Ram went to Lanka, etc., Ramayana is flora and fauna of North India, north of Vindhyas. There's really no evidence that Valmiki knew of anything south of Vindhyas. The third thing is that Ramayana all along talks about Lanka, where Ram went and Ravan was there and so on. But the island of Ceylon or Sri Lanka is actually Sri Lanka. It's a great island.